All right, let's continue with hypothesis testing. So just a reminder that the null hypothesis is the equivalent of a innocent assumption. So you assume the defendant is innocent and you're going to gather evidence towards the alternative, which is the the guilty verdict. Now, in the numerical term, when you go toward a guilty one, it can go above. It can be different from the actual innocent statement, but it can be towards the guiltiness above and above when it's a numerical value. So here, if we go back to the example, in a situation with the IQ of year 12 math students, are they are their IQ higher than the general population? Or the other one with the fuel consumption, is it lower than the previous model? Um, those are examples of directional hypothesis. Um, so here, when you translate that, you're going to say it's the mean is more than 100 in terms of the IQ, or in the fuel consumption, it's going to be less than 13.7. We use the inequality symbol for the alternative hypothesis, and you can also have that's the way we're going to do annotate the alternative hypothesis in those situations. Now, let's say we in a situation we don't know if the fuel consumption it's going to actually be above or lower. In that situation, the hypothesis is we're going to assume it's different from the new model, so it's a non-directional hypothesis, and we have to allow the possibility that the sample mean will be less or greater than 13.7. So the alternative hypothesis is going to be mu not equal to 13.7. So with the alternative, when we now have no direction, we just use the not equal. If we have a directional for the alternative hypothesis, then depending on that, we calculate the p-value will be calculated in a certain manner. So in this situation, when mu is greater than 30.7, so what we consider is the that area, then the p-value will be considered using the area of the upper tail. Okay, so it's a one-tail test. If now we have a more efficient vehicle, so the alternative is mu is less than 30.7, so it will be the p-value will be the area of the lower tail. Okay, so either in that situation above or below, it's a one-tail test. And if we don't specify a direction, so in a situation when its mu is different from 13.7, we have to consider the upper tail and the lower tail. So it's the area of those two sections. That test is called the two-tail test. And now what we can see is it's a normal distribution. You can see the p-value for a two-tail test is double or twice the p-value for the one-tail test. It's just in terms of calculation or on the CAS, you can specify that. So if you calculate the p-value for one-tail test, you double it and you get it for the two-tail test. So here's the summary, that's from your textbook. Okay, example. So pause the video just to come up with your two hypotheses, And with the second part is to find if you determine your p-value and see if you which area are you have strong evidence towards H0 or away from it. Okay. All right, let's move on. With the null hypothesis, so we want the mu to be equal to the mean, which is 200. And to make sure that it's working properly, what we're going to do is non-directional, so it's the alternative test is different from 200. We will need to determine the p-value. We're going to need the sample size as well as, well, we're going to need the mean value of the sample, but also the standard deviation of the population that we're going to recalculate using the sample size. So here it is. The expected value is 200. The standard deviation is 5 over root 15 with the sample size. With the p-value, being a two-tail test, we're going to use the probability of the one-tail test. So it's a probability of the mean sample less than 197.7, knowing that the population mean is 200. We standardize that. We determine the value doing the we can use inverse normal. I'll show you. There's actually a function for the tail testing for the 1 or 2. We determine that p-value. Now, because that p-value is greater than the significance level, then we have no way of rejecting the null hypothesis. Therefore, we do not have enough evidence to conclude that the mean volume of coffee dispensed has changed. Alright, with the CAS, using those the menu and those instructions, you get to that function which is your z-test. You enter your parameters. Here you will specify the type of tail test you're doing, and then in the next window you will get your p-value. Alright, now how do we relate that two-tail testing to a confidence interval? Just remember that from the 95% we relate to that, which is your margin error, and there's a link between the two. So if we have our two hypotheses, and if we carry out a hypothesis test at a 5% level of significance, then we will reject the null hypothesis only if the 95% confidence interval does not contain mu0, which is the value we add from the null hypothesis. So all the values outside the interval will be rejected as value for the population mean, while all the values inside the confidence interval will not be rejected. Alright, so applying that to the last example, we're going to use the information from example 5. And we're going to determine first, you need to find the 95% confidence interval, and then you use that confidence interval to test the hypothesis at 5%. And then you're should be able to do part C. Alright, so pause the video, have a go at this, or just read the question again just to get a good understanding. Alright, so we use a sample mean and a 95% confidence interval, so we substitute the values. So remember, we just use the formula, that formula. Okay, so we get to that, we get the confidence interval. Now how does it compare? Well, since the interval contained the hypothesis mean value of 200, so that interval here, we will not reject the null hypothesis. So it's the same kind of conclusion that we get from 5b. Alright, Now we use a different mu, so 198. Since the interval contains the hypothesized mean value of 198, again we're gonna go with the same conclusion. We again can't reject the null hypothesis. And that's it for 16b, and I'll see you in the next video.